In this video, we are going to look at how to derive the formula that can be used to determine the Brewster's angle. Now, if you are new here, please take a second or two, then subscribe this channel, like and share the video. Now, let's start. The Brewster's angle, actually, it's that specific angle that the reflected ray is completely polarized. Now, we know that this is our incident ray. This is our incident ray, and then this is our reflected ray. This is our reflected ray. And then this horizontal line here is the plane of our mirror. So when the incident ray strikes the surface of the mirror, then it will be reflected back. So this is the incident angle, QI, and then this is the reflected angle, QR. And then this same light can also be refracted by the plane, so it can be refracted this way. And then we find here this is our refracted angle theta. So we're having our incident angle, reflected angle, and then our refracted angle. Then we should know that when light strikes the surface of the mirror, after production of the reflected ray, this reflected ray is to some extent polarized. So in Brewster's angle, we are going to find that specific angle which the incident ray is completely polarized. Now, but from the laws of reflection, we also know that the incident angle is equal to the reflected angle. So this reflected angle, we can call it the polarized angle, which is P. And then having been equal to the incident angle, this incident angle also we shall call it P. Now, from the laws of from the Snell's law, we know that N1 sine theta P, which is our incident angle P, is equal to N2 sine theta r. So this is from the Snell's law. Now, after having this, we should know that here this reflected ray and this refracted ray is sharing an angle of 90 degrees here. This is perpendicular. Now, this angle in between the reflected ray and the refracted ray is 90 degrees. So we can determine actually this, and having this as 90 degrees, and we're having a perpendicular line here, meaning this distance from here to here, it is 180 degrees. Now, when we subtract 90 from 180, then definitely we get 90. So this angle, theta r, refracted angle, plus this theta p, we get 90 degrees. So theta p plus theta r is equals to 90 degrees. So theta r, this one can be gotten as 90 degrees minus the theta p. So this is true from this equation. So we are going to substitute this theta r here. Instead of writing theta r, we shall write 90 minus theta p, so that we can have this equation here as n1 sine theta e is equals to n2 sine 90 minus p here. Now this now becomes our new QR. And from trigonometry, we know that cos theta can be given as sine 90 degrees minus theta, this theta here. So this is from trigonometry. You can confirm from your calculator, so that you can, when we want to find cos 20 using sine, we shall do sine 90 minus 20, so that we get sine sine 70. So cos 20 is given as sine 70. So that one you should know. So after substituting here, we can have n1 sine theta p is equals to n2 sine 90. Instead of writing sine 90 minus p, we can write now cos. Let us use cos, because after finding that we shall use cos. Now our cos p. Cos p. After having this, we want to find n2. To make n the subject of our formula, we shall have to divide on both sides by cos theta p, and then this side also cos theta p. So this one shall cancel out with that, so that we have n2 is given as n1, and also we know that sine theta divided by cos theta is given as tan theta. So this is n1 tan theta. Now this is now our new equation. So divide this side by n1, then this side by n1, so that we remain back with tan theta p is equal to, or rather is given by n2 divided by n1. After having this, so if you want to find the Brewster's angle, you shall have to divide n2 divided by n1. And n2, from our equation here, n means n1 means medium 1, the refractive index of medium 1. Then n2 is the refractive index of, or rather due to, medium 2. So Brewster's angle is given by, the tan Brewster's angle is given by refractive index of medium 2 divided by refractive index of environment, or rather medium 1. This is now our Brewster's equation. This is our Brewster's equation. Thank you for watching.